in the middle of the night. Who knows? Thank you for joining me. My name is Tim Brzezinski. I am a middle and high school mathematics teacher in New Haven, Connecticut. I get to teach kids grade 7 through 12. It's fun. And I love to actively engage them no matter what. I like to call myself app agnostic, although GeoGebra is my favorite. It always will be. And as you saw last session and Tanya and Melanie's session, you saw a little bit more with Graspable Math. Now, many of you only seen Graspable Math in GeoGebra notes in that one setting, but Graspable has its own platform in and of itself, and it's so super easy to use. And if you have students who are struggling with algebra, maybe they're taking an Algebra 2 course and they're struggling with Algebra 1 and you like want to bang your head on the wall, why don't you know this? This app is for you and it's for them. This will help fill in the gaps. For some students, it's like training wheels. And eventually you can take the training wheels off of the bicycle. And for others, it's a continual support of procedural fluency so they can learn conceptually. All right. And I'm going to have you, I'm not just going to talk, you're going to play, we're going to experience it firsthand. So if you want to take your phone out and take a picture of that QR code, feel free. I post ideas for teaching and learning daily on social media. Whatever your favorite is, I'm probably there. Feel free to follow if so inclined, but let's get ready to rock and roll. The tiny URL is right there. So I'll humbly ask if you haven't gone there yet, tinyurl.com/FLGGB23. If you could type that in, or if Kasha or Rob, if one of you could write that on the board, you're there in case you have someone coming late, that would be wonderful. Okay. But let's get started. So let's see here. Yeah. So again, helping students develop procedural fluency. That's the goal. All right. So we're going to learn a couple things here in this 50-minute session, but what you learn in this 50-minute session, I'm confident you'll be comfortable with using on Monday if you really wanted to. Okay. We'll learn how to create an activity, explore different task types, right? We'll learn how to create a student session and see how we can formatively assess all student progress in real time, just like you can do in GeoGebra Classroom. All right, so let's get started here. So now what I'm going to have you do before we do that, I'm going to ask you to go to graspablememath.com, GRASPABLE math.com. This is going to work best if you're actually logged in and have an account. You know how you can't access a Google Doc unless you're logged in to some Google account? Even if it's view only access, you need a Graspable account to view stuff in Graspable typically. So if you go to graspablememath.com, in the upper right corner where it says sign in, would you take a minute to just sign in? I'm assuming through Google. All right, just take a minute to do that and I'll give you time. So, and if you have questions, feel free to throw them in the chat. Let us know where you're from, what you teach. I'll be checking that. I think that's in the Q&A session if you have time, but I'll give you guys a minute and a half to go ahead and create your account so we can have this work effectively. All right, so go ahead. And my kids are playing hide and seek downstairs and up here. So if someone barges through the door screaming, you'll know why. Let's see. So we're creating a Graspable Math account. And as you're doing that, I will tell you that I use GeoGebra, I use Graspable Math. I also use Desmos and Mathagon. I use all four of them.
Sorry, Tim. Sorry, Tim.
What?
Can I ask a question?
Please.
This is Kasia. Hello.
Oh, I know.
You were talking so fast. You talk about so much. Some of us are lost. Where did you get this Graspable Math on GeoGebra? Are you going to geogebra.org?
No.
Oh.
It's the one URL I forgot to put in my presentation. It's Graspable Math and put a .com.
Oh, so this is not at GeoGebra right now.
Nope.
We are somewhere outside, okay? And it's also free, accessible to all teachers and all users. And you just open it and you start grasping.
Yes, I'll show you in a second, but I just want people to create an account first.
Trying to repeat this introduction.
Yep. Yeah, I could put it in the slide here. I don't want to take too much time, but it's basically here. Let's go to graspablememath.com. I'll change it. There we go. And I'll link it right there. Make a hyperlink.
Put it maybe in the chat as well to everybody.
Sure, I will do that. I apologize. I'll send it to hosts and panelists. Here, let me get it with the HTTP in there. Or it's actually activities.graspablememath.com. Here we go. Let's give this to the masses right there. That's a clickable URL. Did you get that?
Yes, thank you.
You're welcome. I apologize.
No.
So yeah, once you get that link there, you want to go to the upper right-hand corner that says sign in, or I would just do it through Google. It's quick. It takes like 10 seconds. Okay. I'll start in like another 30 seconds to a minute, so everyone's all in the same place. Okay. So I love this app because it makes algebra playful. Many students have gone through math, maybe kindergarten all the way up to grade 8. They get to high school and they end up hating math because of their experience. Many of their experiences with math has been a timed math test full of 120 facts that they can't do all of them in 2 minutes. And then they go through school thinking they're stupid, right? Math time tests do more damage, in my opinion, than they do good. But when it comes to algebraic thinking and conceptual understanding in algebra, this app helps support the gaps that maybe have occurred because of COVID, or gaps that may have occurred just because the teacher wasn't that great of a teacher. Who knows? The point is, we could point the fingers, but Graspable Math is a great band-aid, and it also helps heal math trauma for those students that have been truly traumatized by math. Many students are afraid to make a mistake, but here you can make all the mistakes you want in a playful way, but you can learn from those mistakes very meaningfully. And I'm going to show you, you'll see very soon within 5 minutes what I mean. Okay, so back in the slide here, Graspable Math has really two components, just like GeoGebra has two components. You know how GeoGebra has apps and it has resources, right? Tanya talked about apps, and Melanie talked about apps. Tanya talked about the website or resources, right? In Graspable Math, it's the same logic. You have a whiteboard, that's one app. You can just go there by going to math.new. If you click on this URL right here, that's the one Graspable app. There's only one. GeoGebra's got a bunch of apps, 3D, geometry, you name them all. In Graspable, it's simple. There's only one app, math.new, or it's their whiteboard. Go there and start playing around. All right. There's also activities in Graspable Math, which we're going to talk about later in the session. But if I go to math.new right here, I have my students come here all the time. Like they said, let's actually type an equation on like down here. Let's say 4x, let me do 4 plus 6 minus 5 times 3y, right? And then minus plus 2x plus y, something like this, right? And I hit enter. All right, there it is. Now watch this. Talk about the playfulness of algebra, right? You can type anything. If I click on this minus sign here, look at that. Click on that minus sign, it shakes its head no at me. It doesn't like me. If you have older siblings, you and the people in the room that have older siblings, how many of you could raise your hand and tell me, you know what? I've learned what to do by watching my older brothers and sisters get in trouble. So I learned what to do by seeing what not to do. You see what I'm saying? It's the same logic here. If I touch an operation that I can't do first, or I'm not allowed to do because see, these are not like terms, it won't let me do it. I can't click here, but what's the only so? I can add first, right? Right there, and I could actually multiply here, right? Getting that? But the point is, you know what? We can actually kind of play with this and move it here. I can't click that. Can't click that. I can't even click that, but wait a minute. If I click this, take this plus sign, I could drag it over. right next door to the negative 15y. And watch what happens when I click on the plus now. You see what I mean? So teachers, you and your students can use math.new on Monday. Just get out your Chromebook, math.new. You give them a warm up with 4 simplifying expressions. Maybe it's the order of operations. Maybe it's simplifying expressions like this. Well, instead of asking, did I get it right? And you're walking around giving yeses and nos to every student. Why don't we empower the students to empower themselves? Give them this tool, have them type in the expression and start playing and see if they did it right. See, that puts more responsibility on the student and less on you. Now, we have enough we have to deal with as teachers, right? Let's start sharing that thinking load because students need to think more for themselves, in my opinion, right? But that's the whiteboard. You could solve systems here. You could solve equations, inequalities. We won't have time to do it all, but that's just kind of a quick demo to start. And what's really cool is I've used this app to foster discovery learning. If you click on order of operations, for example, you could watch me or just go here, right? In that link right there, this is a pre-made whiteboard. Think of this like a Google Doc. I can share it with you. It's the same thing, right? But if I go to each one of these expressions here, it doesn't like it when I add first. It wants me to multiply, right? And then 3 plus 8 is obviously 11, right? But let's go over here now. Doesn't like it. Does for some reason it yells at me when I'm adding first. Doesn't like it. I wonder why. And so here, right? And so no matter what, it always wants to multiply first. You see where I'm getting at? This is simple discovery learning, teachers. Instead of giving students this PEMDAS algorithm, which they always mess up a lot of them anyway, why don't we just give them some expressions to play with and have them draw their own conclusions? And most students when I give them this activity, kids in middle school, like 5th grade, 6th grade, they play with this. All of them are able to tell me immediately that I multiply before I add, every single student. And so now I just give them a piece of paper with 3 questions that look very similar. Almost everybody does it correctly. Why? Because they experienced it for themselves. They watched their older siblings get in trouble, if you will, and they learned what to do by seeing what not to do. You see what I'm saying? This totally transforms the way how I can have kids learn arithmetic and algebra. And through this, now I can make another file and talk about maybe adding and multiplication, adding and division, or maybe subtraction, multiplication. I can make several sets of these whiteboards. And over the course of 2 days, I can have my students really develop their own logical order of operations of what I do first when I get a complex expression, if that makes sense. See what I'm saying? This is a powerful interface, very powerful, but it's also very simple. Compared to the functionality of GeoGebra, Graspable is much simpler. GeoGebra has like tons of tools, but here I love the fluidity of the playing with the terms. It's just so much fun, and students can draw their own conclusions. All right. Did you know, like a Google Doc, you can collaborate live on this too? Rob's ready to go here, right? But watch this. What if you're tutoring a student remotely who has COVID or something like that? You can actually work live way more effectively than on a PDF. So look at this. I have a whiteboard here. I don't think I linked this in there, but I have the same equation written twice. And so I'm going to solve it one way, and I'm going to give this to Rob Pontecorvo. He's going to solve it another way. So I want to go up here as a teacher. I'm going to hit assign or collaborate live. Watch how simple this is. I click it. I enable live collaboration. Now, anyone to whom I share this link can access it as long as they have a Graspable account, which everyone in the room here does. We just made one, right? So I'm going to go here. I'm going to copy the share link. I can copy it here or copy it from right there, right? I'm going to copy that share link. And Rob, your email open there, dude? I'm going to email it to you right now. So let me see here. I'm emailing it to Rob so he has it. And I just sent it. So Rob is going to go play on the right while I play on the left. All right, let me just go back to that board there. So I just want to solve this simple equation 2 different ways. Now, if we look at it, from this kind of perspective here, most students are used to distributing first. But I'm going to ask Rob to do it differently. Rob, you in there? Rob's getting there, I think. But you can watch students work live in this board here. Again, students, if they're working on homework or it's something outside of class and they're working on a problem, there's Rob doodling. Hey, Rob, can you actually go to the transform tool, please? And just take that 3 and put it under the -15. But Rob, if you go up into transform, take that 3. Would you pull under the -15, please? Just drag it right in. There you go. Let it go. Perfect. Now talk about different ways of doing things, right? Most students don't divide first. The teachers we always teach them to multiply first, distribute, and then you subtract and divide. But why? So click on the division sign, Rob. Go for it. All right. So let's drag the 6 over. How do I undo adding 6? What's the opposite of that? And the kids, it's minusing 6, of course. So click on that minus sign there, and then we'll get what we get. But see, I'm working live. Rob can go ahead and doodle off the same way. But see, just like you collaborate on a Google Doc or Google Sheet, we're doing the same thing here. This is Graspable Math's only app, and it's a whiteboard. A lot of functionalities, not a lot of tools here. You know what each one of these does. You know how to erase. Rob just drew. We'll talk about scrub later, but arrange, you can move stuff around. It's a very simple and sweet and beautiful app to use. I encourage you to use it with your students. Next time you actually give a 1 or 2 warm-up questions, have them go to math.new, type in it, and have them play with it. Okay, there we go. Thank you, Rob. Appreciate your volunteerism there. It's awesome. All right, so now that is Graspable Math's only app. It's their whiteboard. But what we're going to do now is experience it as a student. So if you go over to slide 5, if everybody could jump to slide 5, please. Would you please click on that purple URL right there? And again, if you're watching from somewhere in the world, I humbly ask you, maybe you can make the Zoom window smaller and put your Chrome window on another side so you can see what I'm seeing. I would love to have you experience student and teacher views simultaneously. That would be very powerful here. Okay, so if you can go ahead and click on that sample session there, that would be great. I'm going to go to the teacher view here. Susanna's in. All right, Rob's in. Roberto, I mean. But go ahead, take a couple seconds to go on in there. It's on slide 5. Look at this. Just like in GeoGebra Classroom, you know how you see everybody? If you see my screen that I'm sharing, I could see where everybody is. I tried this activity before. You see that green check mark right there? I finished that task and I did it in 6 steps. During COVID, when I was teaching credit recovery and half the kids were at home and half the students were in the class, and that changed every single day, I used Graspable to teach algebra and I could see where everybody was. True story. While I'm talking, see if you can actually move the terms on that first expression. See if you can make that initial state match the goal state in the lower right corner. I had a student in New Haven. We have the ethnicity is pretty, it's very diverse where we are. So we have kids from all over the world. I had a student who went to visit family in India for 3 weeks. But when it was like 8:30 in the morning here, it was 7:30 at night here, and he wanted to join my class. And so algebra warm-ups, he was able to do Graspable Math, and I could see him working live from thousands of miles away. Awesome, right? But I'm actually going to demo this along with you here. Like, what in the world would we do to do this, right? See, this is called a goal state task, right? The goal here is to get this expression to get to this expression right here. But obviously, I got to click on some things, like me. Oh, I can distribute the negative. If you haven't done so yet, would you pick up the 2 and move it right in? I ask students, what just happened here? And they all tell, you're multiplying every term by 2. It shows the distributive property in action. That's how powerful this is, right? And so now if you click on the minus sign, it'll plow it right through. Every term has to get negated. So what can I do now? Let's see. Oh, I can multiply. Ooh, yeah. And I can actually, those are like terms, but these are not. These are not. 4x and negative x, I can add those, right? When I work with teachers for the first time as students, they always ask me, I mean, I know I have like terms, but how do I bring one next door to the other? There's 2 ways you can do it. I'll show you both. If you click the plus sign that's right in front of the 3x here, just drag the sign. You could drag it anywhere you want. I'm going to put it either to the right or in front of the x. You know what I mean? Now I can go ahead and add. By the way, making algebra playful and making mistakes. Why is it okay to make mistakes? Because I have an undo button. If you don't like what you got, undo it. When you're doing paper and pencil, there's no undo button. It's called an eraser, but it makes a mess. I'm not saying paper and pencil shouldn't go away. There's a time and a place for that. And there's also a time and a place for this, a healthy balance, right? So let me undo that. Another way we can go about doing that is if I just drag the 3. I just picked up that lonely coefficient of 3 right there. If I drag it way, way down, I got to go super far down. You see how the X and the plus came with it? Again, if I drag that 3 far down, if I hold the mouse and go all the way far enough down, I could take it and I can bring it next door. That's another way to do it. So you could grab the sign in front of the term and put it next door, or you could take just the coefficient and drag down far enough so everything comes, and then you can move it next door. Or there's a third, I just realized there's a third way. This sign, you could plop it right on top. Watch this, watch slowly, see? I took that 3x, you see how it turned blue? X and X makes, let go, 4x. When I work with students, I like to move it next door and add it so the students see the combining like terms. But after a few tries, students just know to plop it one on top of the other. They get it, and they move on. All right. And so now, right? But why isn't it's not there yet? Oh, addition is commutative. Again, it is a property that's important, but we often overlook. So if I pick up the negative sign, I can move it to the left. And once you get the goal state, the light turns green. And if I go back for a second, where was I? Zoom is in the way here. Yeah, if I go back to my teacher dashboard, I could see who's done it correctly. I could see right here, Roberto's got it. Selma's still working on it, 7 steps in. Now, Susanna got it, Isabel, see what I'm saying? So yeah, and someone reset it once. I could see how many steps there are. So when I was teaching systems of equation during COVID school, and I had some kids in the room with me, I had someone doing like 85 steps. I walk over to the student and I asked them, I said, you know what? Why is this Hulu commercial that's supposed to take 30 seconds is going 5 minutes long? You see what I'm saying? You could see immediately who needs help and who is doing fine on their own. That's the power of this interface right here, Graspable Math. All right. So, and also, GeoGebra Classroom at the moment, you know how in GeoGebra Classroom, when you click on a single student's work, it gives you a preview, and it gives you a preview. But right here, it's live. So, Anton, whoever's last name is Anton, I'm gonna actually just pick on you for a second. If you can actually do something in there, I want to show you this here. This is pretty cool. The trapezoid right here. So I'm gonna click on Anton's work. Would you please drag the H underneath the A? I can watch a single student work live. Thank you so much. Whatever your first name is, Susan's, I'm not sure, but Anton, thank you very much. Can you drag the 2 right in front of that A? How do I undo dividing by 2? I have to multiply both sides by 2. So let's take that 2 denominator divided by 2. Let's move it in front of the A right there. How many of you algebra teachers, when you solve literal equations with students, that is a very challenging topic to teach and have them make structural sense. But I'm looking at Anton's work right up close. I can have a one-on-one conversation over Google Meet if I need to, or better yet, right in the classroom. This is the power of Graspable Math. And I know as Tanya mentioned, Graspable Math is working, so they're a very close partner of GeoGebra. They are working with GeoGebra on some future projects, and I can't wait to see what that looks like. I'm really excited about that little solver thing Tanya was showing. But Graspable Math in its own interface, in and of itself as well. So right here, get that back arrow, I can go back to the teacher overview page right here. By clicking that button there, I could see the student overview. I could see all the tasks here. You are like cruising, man. Look at that. Look at that. That's awesome, right? Navacha from Mongolia. How are you? Thanks for joining. You must be late where you are. But yeah, so right here, that's what it looks like. But we're not going to do every task in here. We could try to solve, most of you figured out how to solve the equation in task 2, right? Now, I want to show you this literal equation because I think some of us are stuck here. If you all go to task number, I think it's number 3, right? Isn't this a dimes and quarters question? Hey, I have $100 worth of dimes and quarters, and I have to somehow get one in terms of the other, right? The goal is to get this. Naturally, I want to get d by itself. So let's pick up the plus sign and let's move it over. Whoops, let me try that again. There we go. Now I have to divide what? By 1/10. So let's divide by 1/10. And now here's what we do. Because I think some of you are, I noticed some of you, a lot of you are stuck here. Take that denominator of 1/10 and actually just slightly move it up. You see how you have two fraction bars that are blue right there? That 1/10, we're going to distribute that among that binomial up there, right? So every term is getting divided by 1/10. Gosh, dividing by 1/10, isn't that the same as like, wait, there's 10 tenths in one, so isn't that multiplying by 10? Click on the fraction bar now. Yes, baby, there's your 1,000. We're talking, right? And let's move this and let's actually click on the if you click on the fraction bar, it'll make it 2.5. I'll repeat that because I think I just did a lot in a little time. All right. We moved the 0.25q over. Now I'm going to divide by 1/10. In case you missed it, I'll do it again. So it rests there. Now I want to pick up that 1/10 and literally bring it up to the numerator. See how I have the two, I'm holding my mouse. See how I have the two blue fraction bars right there? Let go. Every term gets divided by 1/10. That's my way of distributing across a division symbol. All right. So now let's actually click on the fraction bar, right? Click on the fraction bar, it'll simplify it. And wait, the goal state says the 1,000's got to be on the right side. So let me move that 1,000 to the right. And then we're kind of scratching our heads. Shoot, I know that 5 divided by 2 is 2.5. So why is the light not turning green? Question. In order for the light to turn green on a goal state task, see how all these tasks are called goal state right here? Goal state, you have to meet a certain goal. So what you need to do is you have to rewrite 2.5 as 5/2. So how do I do that? There's a will, there's a way. What you want to do is click on keypad. If you click on keypad, click on a term that you want to change. See keypad, I hit keypad, click on the 2.5. Now what Graspable says, look what it says. Substitute 2.5 with an equivalent expression. And it'll let me do it. So I'm gonna put a 4/14 in here just to be stupid, right? Like, see how it yells at me? Tim, you can't do that. The total of the new expression's got to be the same as 2.5. You are not allowed to put anything that's not equivalent to 2.5. So you see, Graspable is keeping me from making mistakes, but it's still supporting my procedural fluency, conceptual understanding of going from a decimal to a fraction. You know what I mean? So going back here, let's rewrite 2.5 as 5/2. 5/2. I hit enter. Voila, I got the green light. Powerful. Absolutely amazing. You can even solve, again, I'll skip that one, but literal equations, I have activities of those on the site there. Well, let's go to 5 for a second. How do I solve a quadratic? You could use the quadratic formula in there, or this is a simple one enough, isn't it? Let's just bring this over. Here I have two goal states. Yeah, I have one initial state, I have one equation, but I got to get two goals. How do I do that? So I ask students, what do you have to do first? Well, let's take away 4. Many students want to actually, like, many students want to actually square that binomial. I'm like, really? You want to take a chainsaw and cut your steak there? Just use the knife, right? That's overkill. So let's do this. 18. What comes next? Oh, you got to divide by 3. There you go. All right, and then 6. So now, how do I undo squaring now? What's the logic? The trick is to work with this exponent here. Let's bring it to the right side and see what it does. Oh, there's 2 roots. Yeah, because every quadratic, now I remember, every quadratic has to have 2 solutions, a positive root and a negative root, right? Sometimes we keep both, sometimes we trash one. Like Pythagorean theorem, if I'm solving for a side, I trash the negative side because length can't be negative. But if I'm doing trigonometry in the circle, sometimes the negative root is the one I want, and the positive is the one I want to trash. You see what I mean? But here, it acknowledges both. Now, to get both solutions, what you want to do is double click on the plus minus. double click once. If you double tap that, again, double tap, boom, there it is. Just gotta click on the parentheses. Click on the parentheses. And let's actually move this over here and move this over here. And I got my goals. It's an amazing app. I use it to warm up sometimes. Sometimes I use it to exit slip, cool down. Sometimes I use it in the middle of class to practice it. Sometimes students who are working on a problem printed on paper, they want to go to math.new to check something out. Go to math.new and check something out. What's to stop you? It's free. Use it. All right. Just like Google Docs is free. You could type up notes in a Google Doc anytime you want. You could type up beautiful math in math.new and check your results. All right. Now, let's go to the Canvas quickly. It looks like GeoGebra Notes, doesn't it? In GeoGebra Notes, I have Graspable Math embedded in GeoGebra Notes, but this is the reverse. Here I have GeoGebra embedded in Graspable Math. Look right here, right? A white dot next to that equation. Take that white dot and drag it right into the GeoGebra graph. It works in GeoGebra Notes as well. You know that. And so if I move right here, use GeoGebra, I just click on the intersection right there. Oh, there's 23 cows, 77 chickens, right? Here we just solved it graphically. Now, we can also, did I put a system in here? I thought I did, but I'll show you that after. So now there's two more task types I want to show you. One's called line it up. So let's click on this button here. You see the goal here, ladies and gentlemen, is to actually these numbers to get my blue graph. See my blue graph, it says yours. Bigger here. See, my graph is green, but the graph I want to get is blue. So if I press on my mouse here and drag up and down, see, this is called scrubbing. Scrubbing the coefficient. Well, the y-intercept has to be 2, right? So I'm going to leave it at 2. But now I have to mess with the slope. So if I look at this line, I'm trying to think, gosh, that's a nice point on the line. Where else? I think that kind of looks like 1, doesn't it? At 4, 3. So that slope looks like it's rise divided by run looks like it's 1/4 if I'm checking. So I can click on the number and change it to a 1. I can scrub this to the cows come home, right? See how I'm like up and down, 1, 4. Oh, look at that. I got it. This is a task called line it up. What basically, there's the next one. The summary is you click on the button. The goal is you have to match one graph onto the other graph by changing the coefficients. You can scrub them. But you can have, I foster discovery learning here in trigonometry, like a sine b, x plus c, you know what I mean? What does the a coefficient do? What does the b do? B messes with the period, right? C messes with the horizontal shift, and the D messes with the horizontal shift, right? Kids can discover in here too, just like they can do in GeoGebra apps, right? But now if I go here, I can just see that where to go, it's got to come down. And oh, x plus moves it left, x minus moves it over. Got it. Yeah, it's almost like and so it looks like that. And I got it. Okay, that's line it up. Again, we're experiencing this as a student first, but then afterwards I'm going to show you how to build it. It's so easy to build, so easy. All right, hotspot. Let's go to hotspot. I love it when students make mistakes, right? And honestly, I don't like. I was at a talk. I think back. Karen Kemp was at that same talk because I was sitting at the table where she was. But they talked about difference, like people call a misconception. They say like try not to use the word misconception, but let's say it's a conception. Every student has conceptions. It's just that sometimes they're not accurate. I want to get inside students' heads and see what they're thinking instead of being so quick to say, no, you're wrong. This is how you do it. Why not try to understand where the student's coming from? And Graspable Math can help you do that. So notice how I have a marker right here. First line is totally correct. But after the first line, can you all try to find my mistake? I should have put the dot over where my mistake is. Not my mistake, or is this one? Starting in the second line down, everybody to see if you could find my mistake. Big boo-boo here, big no-no. See if you could all find it. And once you find my mistake, please put the dot over it. There we go. Is this task? We're on task 9, I think, right? Yeah, task 9. Zoom out a little bit here. Look at that. Roberto, I could see, look at, if you look at my screen, I could see where Roberto placed it, Selma placed it, Susanna, JR, everybody in my class where they solved it. And look at this. You see that little workspace in the lower right corner there? I could see who's actually working and who's not. And now I'm asking you to explain what you did. You have to type something in order to get the green light. So in that explanation, just type some gibberish, blah, 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 right? And then hit submit or something like that. And once you do, you will see the light turn green. That circle will turn green if you got it correctly. And oh, guys, you're doing awesome. Yes, we know how to distribute. That 2 is a big, right? I forgot to distribute the 2 to the 2. And if you look at my screen as a teacher, you'll actually see that this is where all the dots are. This is an overlay. Everybody has dots here, here, and here, and here. And I could see right there. Susanna got it right. So did Roberto. So I might say, hey, JR, you just got to answer that question here. Could you just explain it quickly, please? Hi, Susanna. And Selma said, help. Right? So kind of like that. Yeah. This is what it looks like. So in order for the light to turn green, you can ask students to reflect anytime you want in any question. Either work in real time, just like I'm seeing yours in real time right now. All right. So again, this is Graspable's analogy to GeoGebra Classroom. Many of you use GeoGebra Classroom. You love, you could see kids work in real time. This is Graspable's version of GeoGebra Classroom, if that makes sense. And by the way, all the graphs that you saw embedded here, they are GeoGebra graphs. Graspable is inside GeoGebra. GeoGebra is inside Graspable Math. Beautiful integration. So you can also, I want to show you one more thing. Task 10. You can actually put a picture with a bunch of mistakes. Here I have a mistake here. Makes sense, right? I made the first line is totally correct, but in every line after that, up somewhere. And I would like you to drag the blue marker of every number that's wrong. You guys all found them. The 12 should not be there. 7 should not be there. And neither should the 5. Moved up the order of operations big time. And I can already tell John got it right. John T did it correctly. A lot of people are still working on this one here. And so that's kind of what it looks like. And once you hit the submit button, you have to get them all to get it right, to get it green. See some other teachers, I could see some people put this here. Again, just asking for the logic here. The answers would be 12, 7, and 5, but you can make up your own thing. I've shown geography teachers in middle school how to use this to identify countries on a map. Just put the dot over the country. It's kind of self-correcting. It's nice, right? So, all right, you've seen the power of Graspable. Great question. We're going to build the same activity, not with all these tasks because we don't have time for it, but within the 10 minutes I have left, I'm going to show you how you can do that. So now, what I'm going to do is go back to, all right, and I'm going to go back to graspablemath.com. Let's see. I put in there. All right. So if you go back to slide 7, and click on that link right there, activitiesgraspablemath.com. That's home base. Once you're logged in, you should see your name in the upper corner there. You want to go to where it says Activity Bank. Under Activity Bank, I'm going to go to where it says Create Activity. If I went too fast, I'll show you again. Back to my slides in screen 7. Go to that URL right there. Again, just like in GeoGebra, you got that menu on the left. Activities are where it says Activity Bank. It's right here. You want to hit Create Activity. Create Activity. I'm just going to call this sample for demo or something like that. Sample. So now, when you go to GeoGebra, Create Activity, you have a blank sheet to edit and make stuff. This is what I'm doing right here just in Graspable Math. And you know how in GeoGebra you have different things you could add? You could add a GeoGebra applet, you could add a question, you could add a PDF. Well, these are the options I have in Graspable Math. There's only 6. It's very simple. I'm not going to show you multimedia because you know how to put a YouTube link in there. That'd be stupid of me. You know how to do that. And also multiple choice questions. If you can do it in GeoGebra, you could do it here. Check the box of the right answer or answers. I'm not going to waste your time. I'm going to show you how to create all 4 of the new ones: the hotspot, Canvas, the line it up, and the goal state. Or actually, I think for time, I'm just going to do 3: goal state, line it up, and hotspot. Because Canvas is just a whiteboard. Like, you know, if in GeoGebra, if you want to put a blank GeoGebra app in, you could just put insert blank app, and that's it. That's what Canvas is really. So we're going to look at 3 types in the little time we have left: goal state, line it up, and hotspot. So let's make a goal state first. Goal state, add task. What do you want the initial state to look like? I'm going to put an equation. Say x plus, I'm going to actually do it, let's say 3x plus 4 equals 5x minus 1. Enter. And see how Graspable, like GeoGebra CAS, Graspable just solved it for me. I mean, it's 21st century. A lot of things can do that, right? So hide the goal state. Actually show the goal state. Remember in the lower right corner, we saw the goal state for some of them, and some we didn't. But I'm gonna hide the goal state. I'll show it. But I also, when I hide the goal state, I'm also going to allow for commuted answers. So if a student gets 5 equals x or x equals 5, it's going to turn green no matter what commuted means. Okay. But that's kind of what there. So now I could just say, go ahead and solve for x. Now, if I want to preview that, if I want to preview it, see what it looks like so far, I can see if this works. And it's going to work. I mean, I could drag it down far. I remember dragging it down far and bringing it over. This is like playing with it as a student. Works. Okay. That's how you do a goal state. You could do a system here too. Let's do another goal state quickly. Let's make it a system of equations. Well, if I have a system of equations, I need 2 initial states and 2 goal states. So let's do a simple one. Let's make the answers 5 and 3. So 5 plus 3 is equal to 8, right? I want to add, look right here. I want to add an initial. Make another initial state. So right here, I'm going to put x, 5 minus 3 equals 2. So Graspable is confused right now. There's a little, Tim, what do you want for a goal state here? I want you to, like, this is where you have to intervene. Here's where you as a teacher got to take it off autopilot, and you have to fly this plane yourself for a few seconds. So that's what I'm going to do. So I'm going to say no. I want students to come up with x equals 5 because I know what the answers are. The goal state now, y equals 5 plus 3 is 8. 5 minus 3 is 2, right? So I'll hit done. I want you to see what it looks like when I demo this. I'll preview it. Goal state. How do you do this? Well, unfortunately, we have to only use substitution here because elimination of program is a lot harder for them. But you see, I put the 8, drag the x over. So where I see a y, put it where I could put it. See, I can make a mistake and put it here. Graspable is not going to stop me from doing this. It's just that I'm never going to get the green light if I do. But I got to go here. I'll bring this X. Oh, I have two X's now. Go here. And then divide by 2. X is 5. And I got to substitute back into X here. See what I mean? And then voila, it works. All right. So that's how I do that. So that's what goal state's all about. So now when it comes to when I know I have 5 minutes left. So let me show you this here. Let's see. So for line it up, this. Let's make a goal graph of y equals 2/5 x plus 3. I'm going to start with this right here. I'll just do that, and I'll hit done. So now when I go to preview that, go to line it up, hit the button. Now if I scrub the numbers, it'll work. If I make that a 2, 5, bring that down to 3, I get the green light. Just type the equation you want. You could pick a starting, whatever. You could graph circles. You can graph inequalities. Inequalities don't have time, but you can do that. Try it. It works. All right. Last but not least, let's do a hotspot. So task. So I got to upload an image, which I have ready here. This was the mistake that I made right here. This was the same picture. Remember this one? All right. Now mark the place that is incorrect. The way I do it is I take my finger on my trackpad or my mouse, and I want to drag a rectangle around the area that's mistaken. See how that was my mistake right there? Graspable will allow you to do up to 10 mistakes. And students have to hit all of them or one of them. Like see here, there's options for you. Can students place up to 1 marker, or do students need to mark up all hotspots? I mean, once you start doing this yourself, it's pretty self-explanatory. All right. Remember, I gave you guys a place to play. If you're not sure what it is, maybe I can give you that initial starting equation. What was it? It was 3x minus 4 equals 2, negative 3x plus 2 plus 15. Done. So that's what I actually did before you guys came in. I just made that and gave you a place to work. If you couldn't find the mistake, play with it until you do. And additional options. I asked you guys to reflect, and I made you reflect, so I included that. And then I hit done. All right. So this is what you can definitely do. And Kasha, if you don't mind me, I know I'm almost out of time. I just want to show you guys two more quick things that I think teachers will fall in love with. Some teachers I've worked with do not like, I'll be super quick, I promise. Some teachers I've worked with do not like the fact that you could drag across the equal sign. Like if you go back to screen, wherever it is, go back to slide 6. Click on that URL in slide 6. Here's an example of where I cannot drag across the equal sign. You see what I mean? It's like frozen. Tim, is it broken? No, it's not broken. What you have to do is press on the equals. And now I have to tell it what to do. How many of you algebra teachers want to bang your head in the wall because kids add 10x to both sides? Well, guess what? This will stop them. Because why doesn't this go to 0? Oh my gosh, there's 20 of them now. If you click on the one way to go about it is clicking on the equal sign, and E means everything, left side and right side. Can actually, whatever you do, E minus E plus 529, it'll actually let you do that right there. And now so you have to literally tell it what to do with both sides. So when I have kids solve equations like 3 weeks later, I turn that off, which you could do in the settings right in the activity for the cogwheel. I can't show you now because I'm out of time, but you could totally do that. I know my time is almost up, Kasha. If there's questions, I can take them. I'll turn it back over to you. For more, you're welcome. There are a lot of how-tos. There are some videos that are very short in the lower slides. So if you really love this program, these things will show you a lot in very little time. So thank you so much, and I hope you enjoy the rest of the conference.
Thank you so much, Tim. Thank you so much. And there are some questions in the chat. Are there any questions here in person? Do you have any question for Tim right now? Too much, yes, too fast, too good.
Well, to answer,
can you read the questions in chat? And because we couldn't figure out, you have Q&A. Thank you so much, Tim. That's okay. Could you show us an example of trigonometry formulas like law of sines? You didn't
Absolutely,
do
absolutely. I could show that quick. If you have to go to lunch or get break, go ahead and do that. You
Oh,
don't feel
that's
like you have to.
okay. We still have a couple of minutes. I don't think the lunch is set up yet, yes?
Okay, so right here, one thing you could find activities. I know I have an activity on the law of sines here. So if you go to the activity page here, type in law of sines. I'll show you an example of it in action. See, I have quick setups where all I want to do here is emphasize proportions, solving a proportion, because I taught this right after COVID hit and students were still struggling a lot of their algebra skills. So if I go to law of sines quick setups, I'll preview it here, but see, like right here, you know,
Okay.
I have a setup there. There's my initial state. There's my goal state. So I think I might have turned off. I think I turned off dragging across the equal sign. Yeah. Oh, I like this now. This is good. Because see, students get too used to just dragging and they don't know what to do. They don't think, but this makes them think. I ask so many students, I don't like teaching them tricks. Oh, cross, multiply, and divide, right? They can't, that's procedural knowledge. That's not conceptual understanding. Conceptual understanding is, hey, how do I undo division? Dividing by the sign of 28. So maybe I should click on the equal sign and let's times by the sign of 28 and then hit enter. See what I mean? And now I can go cancel happy. I'll bring
Okay.
this.
That's some other question. Let's maybe could you show us trigonometry formulas? Like so this is what you're doing. Simplifying the fractions. Do you see that? There's a
Yep.
question
Yeah.
about simplifying the fraction.
Check this out here. Hang on. You could solve trig. You could prove trig identities on here. Totally. Whoops. Graspable.
A link to slides again, Tim. If you'll be so kind to send a link to slides.
Yeah. Let me do that again quick.
Yes.
It's in the. You want me to put it in the chat again?
Yes, please.
Hosts and panelists. There it is. Let me go back and answer that question quickly.
Oh, Samantha. We will try to post it also on our webpage. Yes.
Oh, trig identity. Watch this. I have one here. Check this out. I want to prove, I'll do this in like a minute or less, right? I want to prove that this holds true for everything, for every angle X, right? So down here, I didn't get a chance to, down here, there's a formula section. So you see how, if I look here, see how tangent is sine over cosine? So if I drag tangent right here, see the tangent, I could bring it here. Because we all love sines and cosines. Those are the ones we use the most, right? So right, go to formulas, can go right here now. I can go ahead and move this cosine right up here because that's how I do that, right? So now let's double click on this to add it. A lot of thinking just happened there, but again, I like to have students reflect on and show me what happened. What just happened here, right? And so cosine x times cosine x is cosine squared. Sine times sine is sine squared. Add. That numerator looks really familiar, doesn't it? You know, and so wait, I know there was an identity there. Wait, hang on. Oh, there it is. Look at that. Look at that right there. Oh my gosh, look at this. Done.
Wonderful.
But yeah, yeah.
Okay, some other questions? Do we have here some other questions? One of the question was what is more friendly to work with as a Graspable Math with GeoGebra or GeoGebra with Graspable Math?
Well, that's kind of a loaded question because it depends on what are you trying to accomplish. For example, if I'm trying to, if all I want to do is focus on algebra and procedure, like did you solve this equation correctly? I'm gonna say Graspable is better than GeoGebra. But when it comes to discovering properties of say parabolas or maybe kites or quadrilaterals, I'm going to use GeoGebra's geometry app. You see, every app has its place. If a student, for example, is building something in GeoGebra, I have them use GeoGebra to discover vertical angles are congruent. And then when they see a question on vertical angles with 5x plus 3 and 3x plus 4, how to solve it, I have them take that problem and type it in Graspable Math. So there's a case I use both.
Okay, wonderful. Thank you so much. Yes,
Sure.
thank you, everybody. Are thanking you. Team, that was wonderful. Thank you so much. We stop recording and we will be having now